Hi there, this is Miss Montoya-Rodriguez again, now with volume. And what we're going to do is we're going to work on something that we've already done. We have taken time to find area. Okay, so if I was looking for area of this object, I would measure and find out, use the reference chart, right? We're going to use our reference chart to find area. But we want to find volume. So I want volume, and I want it of this whole piece that's here. So I want to find out more or less, and we're going to make pretend that this is a nice solid, that there's not this little space here. I'll explain why later. But we're going to make pretend that it's a nice rectangular prism. And what we would do to find volume is the first step is we're going to find the area of the base. And we're going to call this the base. This is our rectangle, and as you can see, it's 1 inch this way, and it's 7 inches down. Okay, so we're going to use our reference chart. Remember, the one I gave you, and it's the one that you should be in your binder. We have all kinds of formulas there. We're going to use that to find the volume. So remember, we're going to find the area of this rectangle. So here we have the area of a parallelogram, because this is a parallelogram. It's a rectangle, and the rectangle is got parallel sides, remember, top, bottom, and so the whole thing is a parallelogram. So it tells us that base times height. So we're going to have the base, which is 7 inches this way, times the height. So we have 7 times 1, and that gives us, of course, 7 times 1 is equal to 7. But our area means that we're going to put inches to the second power, inches squared. So that's 7 inches squared. All right? So that quite literally means that we would be able to make 7 little inch pieces down, all the way down, right? 7 inches squared, 7 squares we would have there. This is called the area of the base. Okay? So that will be the base of our rectangular prism, and so we're going to use big B, and we're going to start talking about big B, area of the base. You've got to remember that. All right. So remember, we're going to find, we have found the area of the base, and now we need to figure out the volume. What would it take to fill this up with water if it was hollow? We're going to use, step 2, we're going to actually use our reference chart again, and we're going to look at volume. And if you notice, volume says base times the height, and that is for rectangular prisms, that is for cylinders, for triangular prisms, all kinds of things like that. So what we need to find is we find the area of our base. Remember, this is equal to 7 inches squared. That's what we just did, inches squared. The height here is 4 inches. So we have 4 inches going up. So 7 times 4 is 28. But this is volume. Inches to the third power. All right, so that we would have 28 inches to the third power here. We also call that 28 inches cubed. So that means that we had a bunch of 1-inch cubes. We could actually fit 28 of them in this. Okay. All right, so we're going to do another example using the same piece, but this time on example 2, what we're going to do is we're already going to use the same thing. We already know our big B. Big B is equal to 7 inches squared. But we've got our piece here, right, 7 inches. But what if it was not 4 inches tall? What if it was 20 inches tall, right? What if we had something that was big and we could actually fill it up? Let's say that it was 20 inches tall, and we want to know how much it takes to fill it up. Now, the base is the same, but the height is different. We're going to say that it's 20 inches tall. All right, so we've got a really long rectangular prism. To find the answer is, of course, we're going to multiply these, because now we have the area of our base times the height of the prism. That's 7 times 20 equals, well, 7 times 2 is 14. Bring your 0 down. That's 140 inches to the third power, or 140 inches cubed. And that's how we find volume. Remember, we need to find the area of the base first, though. If you, the height It's just something we're going to multiply against it, but you have to find the base first. Once you have the base, then all we have to worry about is, well, is it this tall? Is it this tall? This tall, this tall, and it keeps going on for a long, long time, right? But we can fill it up with liquid. So anyway, time for me to go play with this. You guys have fun. Write your notes, and we'll see you in class tomorrow. Bye-bye.